Good afternoon to everyone, and I'm happy to continue together with our IN4ACT Researcher team a research seminar series dedicated to present the research streams within IN4ACT project, and this is a second research seminar in the series, and today our co-presenter is Mantas Vilkas. We know him very well at the faculty, and also at he's a member of IN4ACT team. So I think one of a bridging persons between the faculty and the new members of the faculty within IN4ACT team. And I'm myself, Monika Petraitė. I will be a discussant for today. So before giving the floor to Mantas, I would like to invite everyone to place questions or comments again on our chat on the side, but also we will dedicate around 30 to 35 minutes to the presentation. And then again, like last Friday, we will have a discussion. And also, please, while listening to Manta's presentation, think of your areas of interest and opportunities to find the connection points and to collaborate future again along the lines of IN4ACT project interest, which is a long-term project with our faculty. So hopefully we will find a lot of commonalities and collaboration opportunities, both in research and more like in a case writing or practical impact technologies or solution developments for industry. So today our focus is on hands-on in Lithuanian transformation towards Industry 4.0 and current and planned investigations around that topic, the transformation in Lithuania and comparative studies. So Mantas, now floor is yours, and I'll be there to moderate the process.
Thank you, Monika. Thank you, Monika, for the presentation. I'm proud being part of IN4ACT team. However, as Monika mentioned, our objective today is to tell a bit about the research we are doing, trying maybe to find some similar points with all you other. We are ready to share all data we have, as well as we all can contribute and do other research. So today I'm going to talk about Industry 4.0 trends in Lithuania and using some comparative perspectives. And I have three questions on the table today. It's the first one. It's about the diffusion of digital innovations and service-oriented business models in Lithuania as well as in other European countries. Well, later I shortly go, okay, so that's the situation in Lithuania, but what about the star European Union manufacturing companies? And I will conclude, and I would also like to involve you all into the discussion. So what is the drivers and what is the challenges and the opportunities for Lithuanian manufacturing companies to maybe to increase their value added? So let's start going through these topics. Well, first, what was the buzz at all? What's the buzz at all we are talking about? And I think somewhere in the air there is a feeling that digital technologies can provide some competitive advantage that could help other companies or countries or regions overtake other countries, other companies, other countries and regions. But actually, does these huge shifts in manufacturing happen at all? Well, let's look at manufacturing value added in 1991. We see here that we have like the highest producer in 1991 is Western Europe, which contributed 36% to world's value added of manufacturing. When we have North America and other industrial countries that contributed highly to the world's manufacturing value added. Well, the situation in 2011 was a bit different. And the biggest winners, given the period of these 20 years, was Asia, excluding Japan, which increased their percentage of manufacturing GDP by 23%. And the biggest, how to say, okay, maybe losers were North America, Japan, and especially Western Europe, which part in world's manufacturing GDP decreased. Let's concentrate now more on European Union context, because Lithuania mostly exports to European Union and Great Britain. About 85% of all the exports go to European Union. So the dynamics within European Union is the most important for Lithuanian manufacturing companies. The highest contribution, Ireland has 36% of all GDP created by manufacturing companies. In the Czech Republic, 31% of GDP is created by manufacturing companies. Well, we have Lithuania in the 10th position, which where 22% are created of GDP are created by manufacturing companies. Well, and if we look at the period of 2007 and 2017, we see the countries which increased the manufacturing added value to the GDP. So Ireland during this period increased its manufacturing value added by 13%. Serbia is also a winner in this race. Well, the Lithuania, as you see, we had it also positive on the positive side. What about other countries in European Union? We have other countries in which the manufacturing value added decreased. And as you see, these countries are mostly, again, Western European countries. Well, so this competition in terms of countries is happening, and on the country level there is some expectations that digital innovations could provide competitive advantage that would help to take increase the value added by manufacturing. What's the promise? What's the promise of digital technologies and innovations? So, especially in manufacturing. So, especially we talk about digitally enabled business models. Digital technologies for manufacturing companies may allow to enable service-oriented business models, services that support products, but also services that support clients. So services that support products would be services such as training, maintenance, and so on. But we also can provide the services that support clients. For example, consultations which are based on the data collected by products. Okay, remote monitoring, taking over the maintenance activities of our customers. So manufacturing companies are looking to that possibility of increasing revenue from the services supporting products and supporting clients. Well, digital technologies, of course, can allow more effectively to manage internal processes, enabling higher flexibility. That's it. More customization for the products for the customers, to lower costs, or maybe to deliver faster, which can also be an advantage for those companies. And of course, the holy grail of the industry 4.0, it's smart factories, highly interconnected and highly productive. And of course, new factories should be extremely more productive comparing with most established one and incumbent one, especially those those operations are taking place in, I don't know, in old Soviet buildings, and most of the companies overgrow them, and it's difficult to find new places and to continue operations. Good. So let's look at the diffusion of digital innovations and digital services in Lithuania. Let's look if the diffusion of these digital innovation services are contingent on size or industry within Lithuania. And then we'll try to answer if extensive adoption of digital technologies may constitute a competitive advantage. Well, we have to compare a bit. If we will be looking just to Lithuania, we would not understand if we are here lagging or in advance in some sense. So I will compare the diffusion of the same practices with Serbia and with the Netherlands. Well, Serbia, it's close, that the economic situation is close to Lithuanians, and to Lithuania, and the Netherlands are the front runners usually in new technology. So it would be interesting to see in which part we are lagging or in front of those countries. The comparison is, of course, is done while all country is history dependent. We cannot make much conclusions out of that, but we can feel if we are lagging in the diffusion of digital technologies or we are in front of them. And I will use the data collected in 2018 in Lithuania, in the end of 2018. It's a part of European Manufacturing Survey. It's a network of organizations that collect data in European Union about the manufacturing innovations and organizational innovations. So in Lithuania, we collected a sample of 500 firms. And in some characteristics, the sample was quite well represented the population of manufacturing companies in Lithuania. So we actually got quite good representativeness in terms of size as well. The sample was representative in terms of the main sectors of manufacturing within Lithuania, and it was a perfect representation of regions across the Lithuania, east, north, west, and south. Good. So let's look and let's start from the lean methods. Maybe to calibrate a bit. Because we know that lean methods, companies in Lithuania started implementing lean methods about 2006. So we have about 14 years of extensive promotion and spread of quality and related lean methods. And we see what we have here. We measured the diffusion of visual management tools, some quality management practices, pool of production practices, setup time reduction practices, value stream mapping, standardized work instructions, and other methods. And you see the percentage of companies that apply those methods within Lithuania, Serbia, and the Netherlands. Well, what we can say that actually the spread of lean methods, lean and quality management methods is really extensive among Lithuanian companies. For example, standardized work instructions are reported to be used by about 80% of Lithuanian manufacturing companies, which is quite extensive. That's it. The lean and quality methods are really popular within Lithuania. Let's look if the adoption of those methods are contingent on the size or the sector or other internal organizational factors. Well, if we drill deeper, we see that yes, it is. In some part, the bigger organization, the higher is adoption of lean methods. And here we have the big organizations that on average are leading on adoption of lean management and lean management methods. Lean management methods, and we see extremely huge numbers. For example, 93% of big companies, we say that we practice standardized work instructions. We also see, for example, that statistical process control is also in a big companies, it's quite prevalent, as well as involvement into improvement. Let's look if there are some sectoral differences. Maybe some sector uses lean methods more than other sectors. Well, and yes, it is. We see that. I'm sorry. We see that the food sector companies, it's not a huge difference. However, if we analyze means, we see that food sector companies are leading adoption of lean methods. It's interesting the reasons of these differences. Maybe the food sector are more repetitive. Maybe they have a lower products mix flexibility, which could explain a higher adoption of lean methods. After talking about lean methods and somehow calibrating our questionnaire, let's look at the diffusion of the digital innovations across Lithuania and Serbian and the companies from the Netherlands. Looking from the bottom, we see industrial robots, which are used in Lithuania by 14% of organizations, and we have about 23% of organizations are using these in the Netherlands. 3D printing is used about 4.8% of organizations, while in the Netherlands it's used by 11% of organizations. Well, talking about other digital innovations, the situation is mixed, maybe except the ERP software, which is more extensively used by companies in the Netherlands than in Lithuanian and Serbian companies, and it could be that it could be explained, I guess, that smaller companies have fewer investments that we are able to do in the software that allows to control their core processes. Well, let's look if there is a difference in Lithuania based on the size or sector among the diffusion and adoption of digital innovations. Well, we see that it is. We see that the bigger organization, the higher is the adoption of digital technologies. So the bigger organizations tend to employ more digital innovations, which digitize their back-end operations. if you look at the sectorial differences, we can say that engineering industries, which unite the companies which do metal processing and also chemical companies tend to use more digital technologies comparing with other sector organizations. And here also it's interesting question, why? So what are the reasons behind that? And I don't have a straightforward answer. I don't have a straightforward answer for that. It could be related with some associations that that orchestrate activities more intensively in some sectors comparing to others. Well, the last bundle of practices I would like to compare across Lithuania, Serbia, and the Netherlands are practices related with services, digital services, as well as digital technologies enabled business models. Digital technologies enable business models, which is the promise of Industry 4.0 as well. So what we see here, that situation, it's in some sense, Lithuanian companies have only 12% have useful website. It's also only 8% of companies have online configuration tools comparing with other countries. These numbers are quite low. However, in other part of the services, and especially in the sense of digitally enabled business models, the situation is more mixed. It's more mixed in the comparative sense. We have about 5.5% of Lithuanian companies that rent their products, machinery, of equipment. We use such business model as 10% of companies use such business model that client pays for amount of production produced, and 6.5% take a complete management of customers management activities in Lithuania, which is quite a high percentage comparing to other countries. Well, is there any difference in terms of size? And that's it. We find some difference in size, that engineering companies tend to provide more services comparing to other sectors. It may be due that electromechanical products are easier. It's easier to support services, to support electromechanical products with services, comparing, for example, comparing to food or the textiles. And maybe it's inherent differences that engineering industries tend to provide more services comparing to other sectors. And we also find that those companies that produce products customized products, we tend to produce more. Services also, comparing to the companies that maybe have several standard options for the product. Well, let's summarize somehow. Let's summarize what we have here, and I will use the resource-based framework to interpret if adoption of digital technologies, lean methods, or service-oriented business models can provide a competitive advantage. You remember we started from that all the buzz is that digital technologies can be leveraged to overtake other companies, other countries, or other regions. And resource-based framework, it usually says that, okay, you have a competitive advantage if three conditions are met. These resources, in our cases, is lean methods, digital innovations, or digital services, or service-oriented business models, are valuable if we are rare and if we are costly to imitate. So if these three conditions are met, well, we then would have a competitive advantage. So if
Mantas,
these
just a quick comment. We are still in a slide of comparative practices, and other slides moving. We are still in digital manufacturing innovations.
no, it should not be like that.
But this is what we see. That's
okay.
Yeah, I know that there should be much more than this.
Yeah, now it's better.
Much better.
Good, thank you, Monika. So, well, I was using this framework to interpret if digital innovations, lean methods, and digital services can be used for competitive advantage, can be used to overtake other companies, countries, maybe even regions. And I was the resource-based framework says that three conditions should be met. Those innovations should be valuable, rare, costly to imitate, and if all these three conditions are met, well, it provides a competitive advantage. Well, talking about the lean methods, well, we are valuable for sure. We are valuable for sure. We provide cost effectiveness and other advantages. But if we are rare, no, we are not. We are used by 33 or 36 or in Lithuania on average even by 49% of manufacturing organization. So lean methods cannot be provide a competitive advantage as that. What about digital manufacturing innovations? I would argue that we are also could not provide a competitive advantage anymore because we are not rare. We are not rare, and the market of digital technologies are global, and you can source any software, any industrial Internet of Things platform in a minute if the skills in a company is available. Talking about digital services or service-oriented business models, we still see that we are still we are valuable. That's for sure. We can argue that we are still rare among the companies. If we are costly to imitate, I would argue that we are also costly to imitate, especially services that are based especially customers supporting services. Are costly and difficult to imitate. So I would argue that talking about Industry 4.0 technologies, digital innovations, and lean methods, we can argue that at this moment, digital services and service-oriented models may provide a competitive advantage, but other technologies cannot. However, if we cannot provide competitive advantage, it doesn't mean that we are not important, because if all the companies are using digital manufacturing technologies and you as a company are not using it, so you will fall behind. The usage of digital manufacturing innovations enables competitive parity. And it does important to extend the usage of these within the company. Well, to shortly summarize, and I'm already with 2/3 of my presentation. Well, lean methods are very popular in Lithuania, and the bigger companies use more lean methods, and we are most prevalent in food sector in Lithuania. Well, again, big companies use more digital technologies, and they are in Lithuania the most prevalent in engineering sector. Good services, digital services, and service-oriented business models is not associated with size, but tend to be prevalent among firms that customize products to customer requirements, and especially in engineering sector. Well, and as we talk that services are still relatively rare, they could be used for the competitive advantage. Monika, how we are with time? If we are good?
"30 minutes left, so we are very good."
How much you plan to devote for the discussion?
Well, as much as we have, because I believe I don't see questions in the chat, but I hope the audience will engage as soon as we can. Yeah, but still, it's very interesting. So please go on. Yeah.
Thank you.
For another 10 minutes or so, if you need to.
Well, we saw the diffusion of lean methods, digital some of digital technologies and digital services among Lithuanian and other countries. But what about the digital technologies adoption in leading EU manufacturing companies? And we surveyed 11 technologies aiming into the star EU manufacturing companies. So we've been surveying about the adoption of industrial robots, different types, Internet of Things platforms, simulation and augmented reality technologies, cybersecurity practices, and other digital technologies in EU manufacturing companies. Well, we concentrated only to that star manufacturing companies, and the sample was really small, 35 companies. But these they're quite famous manufacturing companies, which usually are interpreted as role models within manufacturing. And it could provide us such as a picture. What about the fusion of digital technologies among leading EU manufacturing companies? In this survey we've been focusing on the technologies, but the main focus was the use cases. In the thinking of each technology, we identified the most important and the most prevalent business cases. For example, 3D printing technologies may be used for the prototyping, but we also can be used for the production of low volume parts. We also can be used for making tools or making spare part production, and these are really the most prevalent use cases of the 3D printing. Well, so all these use cases were prepared for all 11 technologies, and we've been asking if the companies are using or piloting or planning to invest into those use cases in the period of 3 years, or we are not planning to invest. And we got quite detailed picture about 11 technologies and about 66 use cases of those technologies. I will show you only the summaries, and I will set a reference to the report which is publicly available to analyze more precisely about the use of digital technologies among EU manufacturing star companies. This is a summary. Well, on average, we can say that the cybersecurity is the most prevalent technology which is used by 36 companies on average. When we have various off-the-shelf and customized IT applications that augment execution of tasks and processes. Later, we have Internet of Things platforms that are used by 37% of companies. Well, and at the very bottom, we have the analytics and AI technologies that are used by only 17% of companies, leading companies. But if we look at the current, which technologies are currently piloted mostly, so that's it. The analytics and AI is the currently mostly piloted technology within EU. Leading manufacturing companies, same as again the manufacturing applications and Internet of Things platforms. and simulation and augmented reality solutions. Well, it's not to say that as we read the business press, we can think that already all the companies in the world are already applying artificial intelligence to support their business processes. So it's not the case. As we see the closer look, on average, only 17% of leading manufacturing companies applying analytics and AI solutions. However, it's the most piloted technology anymore. But on the other sense, it's also the prevalence of the digital technologies is, of course, much higher competing to all the sample companies. For example, if you remember, about 4.8% Lithuanian companies was using 3D printing, 7.4% sample companies was using 3D printing in Serbia, and in the Netherlands we had this number about 11%. So if we talk about leading EU companies, we have here the numbers of about 28% of companies are using 3D printing. And some others are piloting at the moment the technology. If we look at all those 11 technologies, and it's on the vertical axis, it's adoption challenges. So the higher on the vertical axis, on the y-axis, the higher is to implement the technology. On the horizontal axis is the perception of the companies, which technologies contribute to performance mostly. So if on the right side we have technologies that contribute more for the performance, and on the left side we have technologies that contribute less for the performance of the company. And here are the scores of those evaluations. Well, we see that we see four quadrants, and the technologies somehow go in those four quadrants. So industrial robots are relatively difficult, challenging to implement, and companies evaluate them as contributing to performance, not so much. Well, we have some technologies that, such as RFID, perception technologies, that are easier to implement. However, the impact on performance, perceptual impact on performance is lower. Well, we have the quadrant 4, the technologies that influence the performance quite much according to the respondents. However, they are difficult to implement within a company. It could be that due to the skills and that should support implementation within companies, these technologies. It could be due to some structures that are lacking within companies. It could be due to low integration with legacy systems of organizations. These technologies are quite difficult to implement. However, where influence on performance is relatively higher. And we have here the IT solutions to augment task execution and process execution, and cybersecurity technologies, which are, according leading manufacturing companies, are not so challenging to implement. However, we provide substantive support for business performance. Well, as I say, this is the link to the report, the link on the report where all information from this survey of leading manufacturing companies is presented, and you will find there a lot of information. For example, what's about different use cases of analytics and AI, which are currently used now in the leading companies. For example, we see that analytics of sales and demand forecasting and predictive maintenance is the most prevalent cases that are already adopted by leading manufacturing companies. We also see that Number 2, it's predictive maintenance, and number 4, inventory and parts optimization. It's where these companies are working now. They are piloting analytics solutions in the predictive maintenance and in inventory and parts optimization. For these purposes, we are piloting these solutions now. Well, so if you are interested, please look at the reference. It's available online based on this keywords. So let's sum up. What are the challenges and opportunities of Lithuanian manufacturing companies in the Industry 4.0 context? Well, and I will start from the challenges. And one of the most important challenges is the weak demand environment. Well, Baltic states constitute, like, the population of Baltic states are 6 million people, and it's relatively small countries, small countries. There is the tendency to invest into the factories which are near the demand, and our countries are characterized by the weak demand environment. Additionally, there is Poland, which with 40 million, with the population of 40 million, which we neighbor, and companies that decide to invest closer to customers may choose other countries instead of Lithuania and other Baltic states. Our country and all the Baltic state countries are characterized by low R&D expenditures. In Lithuania, there is only 1% of R&Ds of GDPs devoted for R&D. We have about 2% average in European Union, and leading countries such as Israel devotes about 5% of GDP to their research and development. Well, this is again supported by this is again is a challenge. Is a challenge for the adaptation in the Industry 4.0 environment. Well, the third challenge is, I think it's related to the extent of the future labor force in terms of the size, truly speaking this time. These countries, all the Baltic states, okay, except Estonia, still have a negative population trends and aging society. Well, you all know those figures comparing with peak numbers in 90s. The populations are subtracted by 20 and a little bit more than 20%. And the extent of the future labor force in terms of size looks still very negative, mostly in Baltic states as well in Lithuania. The skills, it's an opportunity and it's a challenge. The availability of scientists and engineers are ranked about in the middle of all industrial countries. By World Economic Forums, which evaluated 100 countries which produce almost all manufacturing GDP. However, the vocational training, which is not rocket science, I guess, it's hardly achieving the results in Lithuania. The ICT specialists percentage of employment, it's 2.7 recently. And the EU average is about 4%. ICT graduates again about 2.7%, while EU average is 3.6%. And in the leading countries such as Finland, we have about 7% of ICT specialists that are 7% of ICT specialists as of the active employment. Well, the skills, especially related to vocational training, we know that we have little in regions, little vocational training related to Industry 4.0 skills, and other skills are becoming a challenge to be solved in order to support and facilitate adaptation in the Industry 4.0 context in the European Union for Lithuania. But we also have opportunities.
Mantas, just a very quick, so we still have 15 minutes left, so maybe you can wrap them really quickly up, because we already have quite a few questions in our discussion.
Perfect. Perfect. This is my last slide.
Fantastic.
We also have an opportunities, and we've been talking today about the usage of digital technologies, and I think that the availability and the use of digital technologies is an opportunity in Lithuania. For example, the slides that I presented previously, we also show that it's a vibrant environment of different adopted different digital technologies and different services provided. But for example, Lithuanian World Economics Forum Industry 4.0 Readiness Index is also evaluated, assessed very well according to the availability and use of digital technologies. We are in the first quartile or something. But it's important to stress that important sectoral and size differences exist. We all know that the small companies, especially micro companies, use little digital technologies, and it could be important and negatively influence the productivity of these companies. The second opportunity is high exposure to regional or global value chains, as about 65% of all manufacturing companies' production is exported in Lithuania. And participation in regional and global value chains, of course, results in knowledge spillovers, also spread of manufacturing practices and other things. Well, and the last thing I would say that actually our economies in the Baltic states and in Lithuania are quite vibrant. The economic complexity, which is a measure how varied is a production in a country, and how ubiquitous the same production is in other countries. It's characterized, our country is characterized quite well, almost in the first quartile. And the part of manufacturing value added created by medium and high-tech industries is about 1/4 at the moment, which could be seen as very low. However, if we would remember that 15 years ago, the Lithuanian Baltic states looked like the manufacturing void mostly, and that all these vibrant 10,000 companies being created during last 15-20 years, that is quite an achievement and opportunity to be confident about adaptation in the Industry 4.0 context. Thank you.
Thank you, Mantas. It was, I think, very rich presentation, and I would really invite everyone to go to the full report, because and to look at the data and think of the hypothesis, because today we were really looking at more like let's say, so the picture or the landscape, like the descriptive situation of Lithuanian industry on a comparative stand. And of course, I have lots of questions, but we have our young researchers also raising the questions, and I'm very happy. So we have Christina and also Mohammed raising their questions, and Christina is asking, continuing on the challenges side. So Christina Kebur is our PhD candidate in management. So she's asking, what are the challenges behind of 3D printing use in Lithuania, as the score is only above 4%? And is it the lack of resources, knowledge, or demand? So do you have any kind of insight? So it's already a research question to
It's
go.
already a research question. We know that in some sectorial differences exist. Some sectors, for example, orthopedics, we use 3D printing quite extensively. However, I guess other sectors are still looking for their use cases, for their business cases. So in essence, where we can use it? Is it for the small part production? Is it for the tools production? Is it for the prototype production? I think most of companies are, except the orthopedics and other sectors who know very well where to apply it, still looking for their use cases.
Thank you. And we have Mohammed also asking, particular more goes into regional economics and developmental economics, how the usage of and adoption of Industry 4.0 technologies can be increased in emerging economies, particularly Baltic region, and also Lithuania naturally. Is it like by improving tech infrastructures, human skills, or anything else? So what would be your opinion? I would actually build up on that question after you go a little bit deeper.
Well, it's a global market of digital technologies. Mostly, it's a global market, and with the cloud availability to use the cloud for sourcing the advanced platforms and so on, it's so fast. And I guess the most important part are the complementary resources which allow to use digital technologies of digital technologies in order to create the value for organization. So these complementary resources are the most important ones, and these complementary resources are constituted by the business process and engineering analysts, as well as that imagine and have experience and have skills of analyzing processes and imagining how technologies can create value. These complementary resources consist of IT and data analysts that, on the contrary, we understand and more the business side, that those all the technologies can and should create a value within a company. So my approach would be through the complementary resources within organizations. That's it, the skills of employees, the skills of managerial skills, of change management within a companies, and ability to create this organizational structures that support the adoption of digital innovation. Monika, maybe you also can add a bit, please.
Yes, I would do. I would do so, and I think what is very, very important here, just to know that there is very interesting discussion going on in the chat. We are also other IN4ACT team members are contributing to the discussion, so so it's quite valuable as well. But coming back to that, I think the problem that both, I think Christina is asking more like in a very focused way, and Mohammed is asking in a more broader way. But I think one of the challenges that we have is, again, is not only like the value added created by industry in total GDP, but value added in exports. And if we look at something which is called TIVA database, it's like trade integration value added database. administered by OECD, we can see that actually the gap between value added in exports is widening between the Western Europe and European peripheries. What does it mean? In a way, it means that we are importing high-end technologies for our manufacturing and other, let's say, so business value creation, and we are exporting lower value added products. So in a way, we are still more a technology importing country than a technology exporting country. And this very low number of investment in R&D illustrates that the firms are still not engaged into the development of complex innovative solutions and start building up their original value propositions for first of all for European value chains, but also for the global value chain. So it's a complex task. And then if we want to increase the adoption, first of all, of technologies, we need to understand how these new technologies participate in value added in manufacturing. So in a way, the managerial capabilities and innovation capabilities associated with internationalization or ROI on innovation, I think is a critical skill, so-called profiting from innovation, because the firms eventually, they are still balancing of this cost advantage or cost profit situation. And of course, the government incentives are not the last to be mentioned here in investment in new technologies. And hopefully with the new changes in promoting of profit reinvestment and technology and R&D investments, we will see structural framework condition changing and becoming more favorable for this adoption, and not only adoption but also use of digital technologies for innovation. And we also have one more question from Manuel, IN4ACT team member Manuel Morales. It's about how do you think the vertical and horizontal integration in the industrial manufacturing sectors in Lithuania could be implanted? So how we can really get to this kind of intersection of vertical and horizontal manufacturing networks, and what are the practical implications for supply chains? Would you like to comment or?
Well, of course, these are important technologies. We have vertical technologies. Usually it's a software that integrates a value chain within a company, it's mostly ERP software and other IT solutions. Well, and the horizontal technologies allow to integrate supply chain and by exchanging information more fastly. And the positive effects of these technologies are quite well understood already. We can share fast information among different supply chain members, which results in less bullwhip effect and other positive things. And the integration of processes within organization allows again to move information more quickly between the processes within an organization and have various valuable effects for organization.
Mm-hmm. That's a good avenue again for empirical and experimental work, I believe, and it's a fantastic question how we can move on. We have we have questions coming, still coming, and I think it's the last one that we can take, though it's 2 p.m. sharp right now. But Evaldas Stankevičius has a question: how much and how combining digital and lean initiatives could increase labor productivity in SMEs, manufacturing SMEs of Lithuania? Did you run, and it's my question, I'm building up on that, did you run any kind of correlation or regression analysis along your data? Like if we combine a couple of methods, does it lead to the productivity increase as based on your data, or do we need more data and more analysis? How all this underpinning of different technologies can bring to the better productivity levels, higher productivity levels?
Well, it's a very, very interesting question. For example, talking about services, which digital services and digitally enabled business models. So at this moment, the community on services are still talking about service paradox. We are trying to understand under which conditions the services have positive effect on the firm performance. So it's not straightforward still. We have to talk about what kind of services and in which conditions and so on. However, talking about lean methods, the community is not divided somehow. It's the operational excellence community already agreed and checked with different methods, so the results are robust that there is a positive effect in most contexts of lean methods on firm performance. Well, talking about digital technologies, the situation is truly mixed. It's truly mixed, and I could not answer you straightforwardly about some extent of the path coefficients and how our digital technologies are related to the performance. This is a difficult question. We have to talk different technologies and then make inferences. Well, and they are still some new technologies such as perception technologies, as well in the industrial platforms, Internet of Things platforms are not the variation. If you survey a sample, the variation is very low. It's difficult to make conclusions still. Also, maybe.
Mm-hmm. Thank you, Mantas. And I think it's a wonderful answer. And I believe that when we already have data at hand, there are lots of questions, and we can really enjoy the research avenues and go in depth. And that's exactly the reason why we are presenting this data. So Mantas is a data holder. And I would say that it's very rich data set, because this is also a comparative data set. And there is really an invitation to collaborate for the future, like a next year manufacturing survey. So in 1 year, which is going to be run again. And of course, what we are also are engaged with its product development, innovation survey in manufacturing, that the first round is like being prepared, where we will look precisely into application of artificial intelligence in product innovation development. So we saw that firms in Lithuania seems to be quite experimenting with application of digital technologies and in product development. So we'll go one step deeper in product artificial intelligence applications in innovating around products in manufacturing. So everyone is very much welcome to look at the Mantas report, which is already published, and really to formulate the research hypothesis as based on the data, and definitely to collaborate with not only with Mantas or myself, but also with entire team of IN4ACT in developing publications and also projects, more like experimental projects applied for Lithuanian industries under the initiatives of SMART or experimentas measures, as we know, and others. So I think it's a good, very nice beginning to start working on hypothesis of dependencies across the factors, or looking at the differences and variations across the industries, and also to look into comparative basis, not only among these three countries, but there are 15 plus EU countries participating. So I think we can really formulate very interesting hypotheses, and everyone is welcome. And I'm really sorry our time ran too fast, as it always happens with research. And I would really like to thank Mantas for this presentation, for contributors from the faculty with the questions, and also IN4ACT team for the great contribution also in the chat version of this meeting. And I don't know, maybe Mantas would like to say something, or someone from the participants still, because I see it's a very busy day today, so some of them already had to leave. But thank you for today, and we see each other again next Friday, so in another seminar. So thank you, Mantas, and thank you, thanks to everyone. So please stay in touch.
Thanks all of you coming here. We are waiting with Monika your, I don't know, emails. Maybe if you want to join on our research, also use data that we collected previously. If you also want to join data collection, which you see are going to be next in the 22 year. And once again, thanks Monika for creating a cozy atmosphere here.
Thank you, thank you, thank you everyone, and have a great weekend. Bye to everyone.